Hello, today we will be solving this arrow pushing mechanism problem, and we will use the 6-point strategy that we have been using in the classroom to solve such problems. So the first step in this is the draw all bonds near the reactive center in the starting material. So basically what we are doing, we are just writing down our starting materials, and if there are some bonds that are involved, we will just write them like this. So this is the only bond that I have written. Then draw all hydrogen atoms near the reactive sites of starting materials and products. So for that I write down these hydrogen atoms. Okay. Now if you are not sure where the reactive site is, you can draw hydrogen atoms everywhere, but here, because this part is not here, so that's why I wrote it down here. Now I should do the same thing in the product as well. These hydrogen atoms help with the assignment of charges. Then the third part is balance the equation. The equation is already balanced. If you write down the molecular formula here, and then molecular formula here, these two will equal to this. So there is nothing to add here. Then number the non-hydrogen atoms. So here I will only number the ones that are near the reactive site, but if you're not sure where the reactive site is, you can number it everywhere. So 3 is this, and then 1, and here if I write down hydrogen atoms, which I forgot in this case for the product, then I can assign 3 and then the other one as 2. So after balancing the equation, then and numbering the hydrogen atoms, I identify bonds made and broken. So bonds made and broken. So bonds made is 1 and hydrogen atom. So in this case I should do this line from here all the way to H atom. Now when we making a bond, this dotted line points to the atom which is more electropositive, and we also know that when you are making a bond near there, is there anything else that is happening? So we can see that this bond is being broken, 3 and hydrogen. So we write down 3 and hydrogen broken, and we can show that with our dotted line as well. In this case, because the bond is broken, the arrowhead should be on the Cl atom. Now this is just evaluating the problem. This is not the actual mechanism. The next is we also can see that 2 and 3 bond is being made. So again, we are making the bond. So from the more electronegative to the more electropositive, and then we also can see 1 and 2 bond is being broken. So in this case, the arrowhead will be on to the more electronegative atom. So once we have done this, then we identify the reaction conditions. We can see that hydrochloric acid is being used, so the conditions are acidic, which means we should not draw any strong bases in this reaction mechanism. So here, once we have done this, then the next step is to actually start drawing the mechanism. The first step is usually the one with the acid or the base or with the catalyst. and here you can see there is the acid, so we will use arrows that involve this acid. So we write down our starting material and see if there are any arrows that are going to the acid, and we see that this arrow is going to hydrogen chloride or hydrochloric acid. So we take this, show it with a lone pair going to hydrogen atom, pointing towards the hydrogen atom, that's the Mole electropositive, and then showing the bond being broken, because otherwise there will be too many bonds on hydrogen. So then the next step is to draw out the product. In this case, this arrow means bond is being made between oxygen and hydrogen. So we draw out that, draw out all of the rest of hydrogen atoms. And once we have drawn the molecule, it's best to balance and look for the charges, and we see that there is a positive charge missing there. This positive charge will help us figure out what will happen next. Wherever the charge is near or at that place, the reaction is going to happen. So we see that the charge is here, and we can see that there is 2 on 2 something is happening, and that is 3 is coming. So we take this and attack it onto this carbon over here and show it this bond being broken to give you this product. Now, even though it doesn't look exactly like this, the number of atoms are the same and they are connected the same way, so it is the product. You may be wondering that here why we just didn't open up here rather than using 2 arrows, because we usually try to use the minimum number of arrows. And the reason here is that let's take a look at what will happen if you do that. If you just take this oxygen carbon bond and break it, so it should generate something that can exist under the reaction conditions. So here we have 2 hydrogen atoms and we have oxygen, and we can see that there will be a positive charge. Even though carbocations can exist under the reaction conditions, this is a primary carbocation that is not resonance stabilized, so it's likely to not exist under the reaction conditions. So this is why this is not a reasonable step to show. In organic 1 and 2, you will not see primary carbocations being generated that are not resonance stabilized. So this is why we used 2 arrows. And that's it. Thank you.